Okay, welcome again. Let's talk about network address translation. What is it? Now, as you can see here, and as we explained earlier, that we don't have enough IP addresses, and the best way for now to solve this problem is to have network address translation, right? So this allows computers to find each other, despite not having enough IP addresses. Now, this is quite impossible. But if we can somehow translate addresses as it goes into a router into individual machines, we can solve that problem. For example, here for a computer, uh, for a computer trying to communicate with this one of these machines inside a private network, right? It needs to have the unique IP address of this machine. However, since we can't really give every machine an IP address because we don't have enough IP address, right? It would be impossible to communicate with this machine within an internal network. Now, impossible if we don't have network address translation, right? So one of the things here is that at the router right here, we can somehow uh, define uh, which which computer it is for, right? So we do this by what we say a network address translation, right? So the NAT actually changes the source address of each packet to a public IP address with a different source port, right? So now when we change this information, for example, if this internal machine here communicates to a machine outside of the a private network, when it's going out, we will keep this information, source address 213 uh, uh, source address 192.168.1.1. But when it's going out, we replace this IP address with a specific router address. So now we have the unique router address that is this this IP address is unique and identifiable in the internet. It's not a private; it's a public IP address. So now it can go into the internet and communicate with a different machine. Now when the machine responds, it will respond back to this router. Now the router will look at its table and see that this messages is meant for this port address, and it will send these messages to the messages that are owned by this IP address. So it would translate back to this IP address and with this port number, right? Now, private addresses in a NAT, right? How does it work, basically? Well, a NAT can protect your internal addresses from being visible in the IP header. It's not really a perfect thing. So, one of the good thing of NAT, when anything behind this NAT is pretty much protected from the outside world, because nobody knows what machine exists behind the router, right? Because they are private IP addresses, and the world cannot really find these IP addresses, right? Because the IP addresses really does not exist after this network address, right? After the router, because these are all private IP addresses and they're not published, and not it's not like you can find it over the internet, right? So some applications will encode addresses in the data anyways, and if you want to connect this, and if you want to connect to the outside world, this would you cannot really find these private IP addresses. So so when it's not routable, and these are examples of private IP addresses, 10.0.0.0, right? This is a /8 CIDR range. We have 172.16 and 192.168.0.0. This is class C, class B, class A. The difference is on the range that you can define it. Now when you do this, basically private IP addresses are not accessible from the outside. In order for it to exist, then the NAT actually will provide you with this routing table. So that's just how NAT works, right? Next we're going to talk about ARP, how this addresses is translated from MAC address to IP address. So we're going to go there next, right?